This is my speedometer for measuring how fast objects go. There's two infrared kind of brake beam sensors here. One right, let me start it up here. One right here and one right there. And when it breaks both of them, we're going to get here that it's going to calculate the speed. If you trigger one of the sensors for long enough, but don't trigger the other one, it'll time out. So in case you get like an accidental trigger, it doesn't calculate the velocity, and like hold that in memory, and then you go quick, it'll calculate the speed. We can also press this button here to update the unit. So you can see I'm having some debounce issues here that I need to work on. And then here we have it connected. This Raspberry Pi Pico is serving as the debugger, and this is the target board. This is the one that is controlling this guy right here. You can see the sensor times out for a little bit. I can press the button to wake it back up, and it's pretty fun. So definitely something that I'm planning to finish up here so that I can use it with my classes. Initially, I was going to try for a hardware solution for these LEDs, but they were very dim, and so I switched to controlling them with the GPI pins. So this is my submission for the Embedded Systems project. I didn't get the write-up finished, and I'd like to do some more work on the project itself, but I ran out of time, and so I'm going to submit what I have. And also, since I don't really have the write-up done, I'll share some things that I learned in the process of doing this project. So last week, I decided that I was going to do it on the Raspberry Pi Pico instead of the STM32. I've got a discovery board over here. And the reason for that change was just because I was curious about using the Pico because I had a couple laying around I hadn't used. And then I'm actually taking another class where I'm using the STM32 quite a bit. And so I figured it'd be an opportunity to learn something new. And it was quite the opportunity. I learned a lot of new things. First of all, just installing the toolchain wasn't too bad. But so I had to learn how to use CMake, which I'd never worked with before, and that was quite a challenge working with CMake. But I got that working, and then it was a little bit more difficult installing the debugger, but I've got it installed now, and it's now configured to debug. You can see we're in debug mode now. I can set a trigger into like an interrupt. So I'll set a breakpoint here in this interrupt, and then I'll press the button, and we'll see that it's going to stop right here when the button gets flagged. Something that was interesting about working with the HAL library for the Raspberry Pi Pico is setting the hardware timers was pretty easy to do and really useful. And so you just have like an alarm callback, and so you initialize the alarm and then you just record the ID in case you want to disable the alarm later, or you can use the alarm ID as well in the callback to see if it was the alarm that for a particular event. So some other things that I ran into, as I mentioned, I had originally planned to control the LEDs using transistors that were triggered by the infrared sensors, but you can see the difference here. This was with transistor switching it, and this was with the GPL pin switching it. And I mean, this is probably just because I lack the knowledge of the electrical engineering to get this to work right. But so I made that change. Another thing I ran into was that with the library I had used for the STM32 for the this display, I brought that library over to the Pico and made the changes in it so it would use the Pico I2C. But what you'll see is it like kind of like scrunched the information at the top of the screen. And what I figured out was that so it's like organized in pages where you have like a kind of a set of 8 pixels going horizontally. Okay, so this library was for the bigger display that was 64 pixels or 100, yeah, 64 pixels tall, where this one's only 32. And instead of using like the first half of the buffer, it uses the odd numbered bits in the buffer. And so it took a minute to figure that out and to get that to work, but that was a challenge I faced. Had to kind of fix that library. And then something that was kind of fun was just kind of adjusting like the precision based on the magnitude of the output on the screen. We'll go ahead and take a look at the code now. Okay, so if we take a look here, this is kind of the main function here, where I call the initialization functions and the state manager function. And so everything is handled in this state handlers document. But so what I went ahead and did, I split out the alarms, so the enabling and disabling and handling the alarms here, and I did a alarm type struct to kind of contain the information for those alarms. For the display, this is just the specific functions for displaying the speed and for clearing the display. And then we have the right here functions for saving and storing the kind of default setting in the flash memory. I haven't messed with this at all, so these are some things that I found that I'm going to try out, and I haven't used them yet. And then we have the driver for the display, and the big change I had to make to get it to work was just right here for the 32-bit display, or for the 32 pixel display. And it's entirely possible that there's also a hardware setting that like a configuration that I missed, and so that's something I'll dig into deeper. And so that was the change that I made. And then down here at the bottom, I modified these I2C functions so that they worked with the Raspberry Pi Pico. And so that's the kind of just a short overview of the code here. Some things to do for the future. Would like to kind of work on what the display output looks like. Probably make the text a little bit, the numbers a little bit bigger. Definitely need to work on debouncing the button a little bit. Need to consider what solutions I want to use for powering it. And really in the end, I'll probably, if I were to manufacture this, or at least do even small scale, probably make these for my class, I'll probably go and use a different chip besides the RP2040. Something that I would be able to hand solder myself, like a surface mount thing. Whatever really I guess would be available and cheap though. So there's that, and then got to figure out the battery. If I want to do a rechargeable battery, probably want to include a power switch. I need to go back and I need to figure out how to do that long-term memory storage. And so thank you for watching. I just want to say I really enjoyed taking the class and learning from y'all each session. It was a great experience, and I learned a ton. It was something that I signed up for knowing that I might be too busy to get the most out of it, but it seemed like a really good opportunity I didn't want to miss out. So thank you all, and hope to interact with you in the future.